From telco to ICT SP, I'm not talking only about carriers, I'm talking about any entity in the ICT space. And as traditional telcos, we move data through space which is called transport. Other entities in the ICT space either store the data or move the data through time or process data, which is called compute. So we have transport, compute, and storage, and all the services we deliver today are basically made of those three. Some of them are traditional, some of them are new, some of them are location-based, some of them are more cloud-based, but this is the environment I'm talking about, and every service any ICT service anyone delivers is made of those three elements, those three basic elements, and obviously some software to manage them all three. So what are the assets of an ICT SP? First, we have the physical assets, which could be the physical locations where they exist, unis in case of a telecom provider like enterprise, government, domestic, telehouse, data centers, locations where we are at. And there we have switching and routing devices, and we have compute devices, we have storage devices, depending on the type of asset. Then we have the connectivity assets, which basically means the connection between all those elements, things that connect them together. They could be node to node, node to ENNI, ENNI to ENNI. ENNI stands for external network to network interface. Then we have the partner relationship assets, because we're not alone in the world. Every ICT SP is in some sort of relations with a few other ICT SPs. And the first relationship asset is the ENNI. People may think of ENNI as a physical asset, but forget about the physics. I would not be an ENNI if there was no need for it, because it's an expense for me, right? I need to dedicate a port and maybe even pay for a connectivity from my device to another. This is actually a part of a relationship asset, because once I have an ENNI, I can build the commercial relations with my other ICT SPs over that ENNI. Commercial and operational agreements with ENNI partners, consortia privileges sometimes, etc. And last but not least, of course, the customer relationship assets, our existing customers, be them enterprise customers, existing relations, services which typically add to stickiness, and sometimes even exclusivity and coverage, which still happens in certain locations around the world. If we try and take this environment where we see there in orange in the center, one ICT SP, and then we have the gray, yellow, and green other ICT SPs with which we are in connection, and then we need to deliver services across those, because with all due respect, hardly any ICT SP can deliver services alone on their own network. Typically, you would need some assets from someone else to deliver end-to-end, sorry. What we did in MEF 18 in last November in Los Angeles was we brought a group of, you can see, 7 different service providers and two vendors. And we actually built a simulated network of multiple carriers connected together. And we tried to deliver services on demand from one point to another point across this mesh. This actually won the Silver Award at the MEF 18 POCs. But what we did discover was that it requires a very high level of integration and standardization versus a very siloed reality. Because as we mentioned yesterday, every telco has their own silo, has their own way of doing things on their own network, and they're so much in love with that silo that it's very difficult for them to change it so it can interface automatically with other carriers. So we had to take many assumptions, which I'll discuss later on. But I do want to tease your appetite with a success story we had in a different field, which is not data on demand, which is actually wholesale voice settlement, where we have been able to reach significant improvements in timelines and in cost reduction. So just to give you an idea of where it could lead and why we actually want to implement the same success with data on demand. This is the current wholesale voice process. I will not go through it in too length. There are 2 carriers, could be for this respect, PCCW Global and Colt. And then, we sign agreement, we exchange rates. it is very simple to define the commercials behind wholesale voice. All you need to do is define a list of destinations, and then you have a rate per minute of traffic to that destination. And you simply exchange that rate every month or every week, and you load that into your switch, and then you start exchanging traffic, and then you automatically collect all the records, you know, all the calls, you calculate their length, and you end up with an invoice. And that's where the automation stops, and we receive invoices. There is always some sort of discrepancy because we measure on our switch, Colt measure on their switch, and things don't work as it should, you know. We billed them $1,000. They think they only owe us $990. We stated 1 million minutes. They thought it was 1,100,000. There was discrepancy, and now we need to resolve that. And we're talking about cumbersome manual resolution and settlement, which typically takes between around 8 weeks. What we did was we basically exchanged those human factors with machines. So we exchanged the humans with basically blockchain nodes that calculate that and reconcile. And we have reduced the time, reduced the humans, or the systems to one system. We reduced the humans to 0 humans. And we reduced the timeline from 8 weeks to 3.5 minutes. So this is significant. I mean, this is not a 20% reduction. This is not a 50% reduction. We actually reduced 2 orders of magnitude, from weeks to seconds. Sorry, minutes, okay? So we want to try and translate this success story to data on demand, because in voice, with all due respect, all we can achieve, of course, is simply cost reduction. With data on demand, we can actually achieve new revenue streams because we can now start delivering services which we simply cannot deliver today because we're just too slow. So I will skip the architecture. It's not, I mean, this is a blockchain architecture. I'll skip those slides in the interest of time, which is running out quickly. And let's go to data on demand. So back to that slide, right? Multiple carriers, each having their own language, each having their own way to define their services. What Cutterworks, which is the vendor there in the center on the top line, did was they developed a standardized catalog. So it's now easy to search their catalog. And for the purpose of this POC, they actually improved their catalog. So it doesn't only respond to a query by searching itself and saying yay or nay, and then offering a price if yay. It also refers to other catalogs in case the answer is nay. If they find no entry in their catalog, they they extend the request to another catalog, and then basically to infinity, we simply put an end, said, don't search more than 4 hops away, just for usability. So through nested catalogs, we were actually able to get a quote that runs across multiple carriers without even those carriers knowing who is the next carrier beyond their own neighbor. So I do know who my neighbor is. I send a request to my neighbor. My neighbor then sends a request onwards to the next neighbor. I don't know who that neighbor is. And they did build a mechanism to, of course, to avoid the closed loops, to avoid feedback loops. But it succeeded. We got a quote back in 1 second. Less than 1 second, in fact. Today, quotation takes between 1 week to 1 month. We got a response within 1 second with one condition. All catalogs, we're using the Cutterworks catalog, and all entries were in a very standardized format of a catalog entry. A location, price, based on time, and the bandwidth related, and the quality of service. Keep in mind, with voice traffic, it's very easy. The commercial agreement is very easy. All you need to do is define the destination and the rate per time. With data, it's quite complex. Do we charge by the mile? Do we charge by the quality of service? Do we charge by the time? Do we charge by the bits? Do we charge by the maximum consumption over a period of time? There's no standard, so we don't speak the same language. That doesn't really work. Okay, so this is how we operate today, right? We have our BSS portal where we sell services to a customer. It could actually be, I mean, in an automatic fashion, it would be a portal or a northbound API or a salesperson going and knocking on a customer's door and trying to sell services. In order to deliver the services, we have our own network, and sometimes we complement that with a few other carriers with which we reach agreements, specific agreements. And at PCCW Global, we have about 180 of those. And then we sell applications, we sell a solution to customers, connectivity, compute, whatever it is, video conferencing, storage, security, everything on our own network. And so ICT SP is offering applications operated through a commercial and operational platform over the ICT SP's network, which sometimes packages some interconnected partners. And our competitor does the exact same thing. And they compete with us using their own arrangements. But if I need to get services from that carrier, that thing is still manual. That thing still takes weeks to months to order and deliver. Where we want to be is to exchange that to a slightly more evolved, and this is the slide I claimed IHS were actually stole from us, right? Similar. So, because this federated and this intermediated commercial and operational framework basically says ICT SPs compete on apps like we did before, cooperating on a federated commercial and operational disintermediated network. Disintermediated, which means there's no someone controlling that network. It's controlled through federation. And then it runs over a mesh of interconnected autonomous silos, which is the existing network. Today we have a mesh of interconnected autonomous silos. This is where we want to be. How can that be done? How can that be operated? If you look at the LSO, MEF55 LSO architecture, this is sort of, I turn it around, but this is the Cantata interface, right, between the customer and that platform, which is basically multiple BSS solutions of multiple carriers working together. Over there, that federation framework is, in fact, the Sonata interface, and possibly also the interlude interface, which we question if it is actually a real interface or maybe it's just a subset of Sonata. And as you can see, this is the BUS part, the business solution part of LSO, and this is the orchestration functionality, the soft functionality, which I actually cut into two halves. Half of it is actually running on the actual network. Half of it is actually sort of related to the BSS platform because it deals with the end-to-end, with the east-west kind of interfaces. So as part of that, we're now starting a new project in MEF 55.1, which is intended to enhance MEF 55 and make it more suitable to tomorrow's interface. How does that actually work? Let's take two carriers and let's see how a query, a quote, works. So there is inquiry coming in, there is some sort of a decomposition of the requirement. We identify what is served in-house through our own catalog, and the catalog responds with either yes or no, and then whatever we cannot deliver on our own network, we simply hand off to the next catalog, which is operated by the other carrier, and this can, of course, go on for ad infinitum, and eventually, if there is a quote coming back, we reconstruct our part and the part which we received from our counterpart and send a quote upward. This guy takes that quote, adds their own services, and quotes back, and eventually the customer receives an end-to-end quote. As stated, we demonstrated this can happen across a chain of 7 carriers within less than 1 second if everything works fine. I guess in real life with latency, it will probably be 3 seconds, not 1 second. Same goes with the service delivery. I send an order, I deliver my own part, there's an extension and that guy delivers their own part, there's an activation request and we service chain everything together, and again service chain everything together, and eventually the customer receives the end-to-end service. Same goes with usage and metrics, etc. And obviously same also goes with payment. I send my payment request, there's an SLA negotiation, reconciliation, possibly some credit calculated, everything is done automatically. We proved the order again to be able to go through within 1 second. Activation was simulated, so that's probably not the real thing. In real life, when we deliver services on our own autonomous automated silo, it takes anywhere between seconds to minutes to activate a service on our own silo. So add multiple silos together, it will probably take a combination of those, but we're still talking about probably minutes to deliver end-to-end service across multiple carriers, even if they operate in silos and not simulated. Hopefully, maybe I'm too optimistic. We may be able to deliver that on the next MEF 19 POC in October. We're still debating. If anyone wants to join, welcome. This is kind of like a prototype of a perspective of how things work in such an environment. There's a selling business unit, and then there's an external SOF, which I mentioned, which handles the east-west, and there's an internal SOF or OSS that handles the own silos activation. And this, of course, can run through a traditional network with whatever EMS or NMS that you're using, or it can run through 5G, ONAP, ODL, others, any kind of network that adheres to this approach. And this is just a flow of a request coming in, being analyzed, internal cost, external costs, etc. Again, this is just a very draft representation that is going to be discussed in May 55 over the coming, I guess, few months or year. So I did mention blockchain for a second, and why did we actually use blockchain to deliver all that? Blockchain is kind of like, it's a buzzword. You say blockchain, everyone's ears, that's the new thing, Bitcoin, money. This has nothing to do with Bitcoin, it has nothing to do with cryptocurrency. We actually did not even transact money here, we just simulated everything. We did use blockchain because it's a ledger that's not operated by a single entity. It's operated by everyone, which makes it very suitable for a federated environment. So if we want to carry data that is shared between carriers but still retains anonymity and is not controlled by a third party which might be biased, then we turn to solutions such as blockchain. So it is owned by everyone, not by someone. It is located everywhere, not somewhere. It's the federated architecture of the multi-SP environment. It disintermediates third parties. So we're no longer reliant on remember the May East and May West days? When you had to transfer all your data through a third-party intermediator, and it ended up with everyone building direct connections with each other because the May thing just didn't work. And it offers reputation management, SLA and financial. So if I go through that chain of 4 carriers or 6 carriers to deliver my end-to-end service, and I have 2 possible routes, I don't know who the players are on those 2 routes, but this system allows me to know that there might be a rotten apple in one of those routes. So it is cheaper, it costs less, it even maybe offers a slightly lower latency, but there is a reputation issue with one of the carriers without naming who it is, and I'm able through that system to now make a calculated decision. Do I want to save money and enjoy the lower latency, but take a risk that there might be some issues? It could be payment issues or performance issues, like packet loss or so. Or they want to play it safe, I will pay a bit more, and I will go through a slightly longer latency, but at least I'm sure that there is a better SLA guarantee and there's no rotten apple along that path. So again, this is something that blockchain allows us to do through anonymity of a shared ledger. And then it also has computational and transactional capabilities within the ledger itself, which can eliminate a lot of the BSS, OSS overheads. Keep in mind, again, we go back to the wholesale voice platform. A typical carrier has about 8 different systems that handle the voice. They have the switch, and then they have a rating engine, and a billing engine, and this engine, that engine, about 8 different devices. We were actually able to reduce that to 2. The switch, which is still a device that does the call switching, and the ledger. And the ledger does everything else. It rates, it calculates, creates invoices, settles invoices, and even handles the payment within one system. So this is actually a serious cost saving. So this is why blockchain is an interesting solution for that. How do we try to handle that? So we're now setting up we just issued an RFI that is due in about 2 weeks to several vendors, asking them to look. This is basically, the picture I showed earlier, right? This is the federated OSS BSS, federated organization, and this is the mesh of networks. There will be some sort of governance because we need to agree who can actually be considered a carrier, an ICT SP. I don't want every Joe Schmo to say, I'm an ICT provider, I'm part of this game. So we do want to understand that whoever participates is a valid participant. But beyond that, we have the use cases. Wholesale voice, data on demand are just 2. We have some common functions, which are things which are common to all use cases, such as identity, payments, And then we have the DLT, the distributed ledger technology, the ledger itself at the bottom. This is kind of like a very, very high-level architecture. Very, very high-level architecture. Why governance, as I explained, it defines the rules of the game. This is basically what standard bodies are doing today. We define the rules, we define the standards, we operate. This is a permitted ledger, so we need to permit people to participate, and we need to manage the software development. Today, all blockchain developments are proprietary, and we want to try and remove proprietariness and open it, turn it into an open market. So this is how the BSS OSS platform of the future might look. Again, we're just taking that one box of the federation, which I showed earlier, and we have the DLT at the bottom, which could be any kind of ledger. There's you probably heard of Hyperledger, Ethereum, Neo, and there are hundreds of other kinds of blockchain ledgers. There are the common functions I've mentioned, identity, payment, and others, and then there are minimum viable products, which are the use cases, and we just want to have the minimum as a standard, and then every vendor can add additional features which are beyond the basic functionality. So we're going to define those. So we have wholesale voice, mobile roaming, Bennett on demand, IoT. There probably be additional features such as security and others as time progresses. And of course, one of the requirements is that there is interoperability with the current legacy OSS BSS platforms, because we do not expect the migration to be overnight. We're probably going to have quite a few years of the new OSS BSS platform and the legacy OSS BSS platform operating in parallel, with possibly some sort of a middleware layer in between. And that basically is my last slide. I still have 2 minutes and 52 seconds. So if there are any questions, I'll be very happy to answer.
Hi, Shahar. That was very good. How does that blockchain fits into? Is it into the MEF as a project? Because I know you did a proof of concept, but where do you want to do this governance? Is that going to be part of it? Is it a subset of as part of the MEF, or is it?
We're actually handling that through GLF. If you've heard of GLF, GLF is a consortium of about 30 carriers. It is actually made of CEOs. It is not a technical forum. It is a CEO business forum. And it has, the CEOs are primarily like the 30 bigger carriers. And we also are in touch with i3 Forum. So those are more commercially orientated groups. So it was GLF that issued the RFI. And I'm just handling their technical team. But it is actually driven from the top by CEOs who see the commercial value behind it, and not the technical solution. Basically, they figure out we need to solve the commercial problem of looking at the problem from a multi-carrier perspective, and then technology will solve how things actually drill down to the network. So once we reach this, this is kind of like high-level reference architecture. We will break it down into lower level. We will probably need to go back to MEF or other standard organizations in order to conclude the certification processes and others, because after we do that, and let's say within 2 or 3, hopefully 3 months, we're able to come up with an agreed-upon architecture and some sort of at least a skeleton of an information model. We now need to cache that down. We do not want to run that through standard bodies because it typically takes 4 years. But we figured out, if you take a typical project in a standard body with an hour a week, that means 50 hours a year, right? If you take all those people and just lock them in a tropical island for 2 months, they basically do the 4 years of work within 2 months, right? And they also enjoy some fancy drinks and stuff. Even though
let's do it in Hawaii, okay?
Yeah, you mentioned my food and drink, but unfortunately, it looks more likely it's going to be in a dark basement in London than a tropical island. But whatever. And
when you were talking about the voice blockchain, and you said, "Oh, we've already done that" or something. So that was just between yourself and Colt. That was just, again, just a proof of concept. It's not that
Well,
nothing is up and
It
running.
started with the bilateral between us and Colt. It then grew to six participants. We scaled that up to 6. So we had Telefonica and Telstra and Orange and BT joined, and who else? Did I miss someone? And whatever, 6 altogether. And now A1 is joining as well. And now we're trying to scale that from a POC to a testnet, which will actually drive real live traffic, not just simulated. And we want to scale that because, the market itself ends up at around 3,000 ICT providers out there, right? And we're only at 6 at the moment. Other questions? We're out of time, but I don't know, up to you.
Quick question, James? Before you ask. You're recording.
Thanks. It's James Crawshaw from Heavy Reading. I didn't understand about how the reputation management would work. So how would you capture or quantify that in the blockchain, the reputation of each service provider?
Well, the ledger works in a way that there is a bilateral ledger between each pair of carriers. So if I have 5 carriers, I'll have 5 bilateral ledgers with each carrier just to reduce the load from the public ledger. Then there's another public ledger which handles reputation. And through cryptography, you're able to translate performance of a carrier without identifying or without revealing the name of the carrier. So, there are ways. I can wave my hands and say, there's a lot of code, a lot of AI in it, but basically, blockchain has the ability to identify fraudulent activities or late payments or SLA breaches. And then it records them, associates them with carrier X, and I don't know who carrier X is, but if I know there's a carrier X in my chain, and then I know I should be aware of that chain, and maybe, in that route, and maybe pick another route which has carrier Y instead of carrier X.
All right. Well, we're going to move on. Thank you, Shahar. I have some questions after.
Okay, well.